Right, so I'm going to do a new video, and this one's going to be on converting temperature to Fahrenheit and so forth. In fact, the question is over here. It's a little exercise, and it's actually quite an interesting. This big PDF file. Just see what page it's on. 73. Let's go back up. It's Python programming. Um, it's an oldish article. I'll zoom in a bit. I'll do plus plus a few times. Just zoom in. 2019. But like, if I quickly scroll through it, we can see some stuff here. Um, Python programming for science and engineers, and we can see kind of like what it's about. And it's kind of like, I've read this before. It's an interesting. It's a quick read actually. It's only what is it, like 130 pages, and lots of it's code anyway. And a bit, it tells you like different stuff, the new age of programming and so forth. For Python is one of the new languages, and it's become more modern and all the rest of it. Anyway, this guy goes into classes and then he asks this question. So I'm going to go back to page if I can. Oops, back. Right, let's see if I can get to page 73 somehow. And you can see all of the stuff as I scroll through it. 60. I could go through loads of these, and I probably will actually. I might do a live one as well while we're here, like a completely live one. So Python modules. A module is a file containing Python definitions and statements. The file name is the module name with the suffix .py appended to it and so forth. Anyway, it gets down to this bit. We will create a Python module with two functions. The first function should convert Celsius to Fahrenheit, and the other function should convert Fahrenheit to Celsius. And the formula for conversion is this, and likewise is another conversion over that. And actually, over here he gives first we create a Python module. So I sort of like omitted this and went straight to the question. So maybe I could have had a look at this. But here's the function that converts centigrade to Fahrenheit, C to F. That's what he means, and that's good naming, by the way. And then Fahrenheit to centigrade is the other way around. And that's kind of like the little formula. Then we create a Python script for the functions, so it gets all stuck in there. And I guess he does some imports this way. So he's demonstrating how you can put this into a file, basically. I think that's pretty much what the demonstration is and how the conversion is done. Exercises. Below you will find different self-paced exercises, okay? And it's quite easy. Where is it? Let's go to it. 73. Read data from a file. Okay, I think we've gone past it. I wonder if I can find it there. Right, I guess that's in modules. Let's just see if I go further down. Chapter 9. Exercises. No, I've sort of like lost it there. File handling error in Python. Right, let's look for S-I-U-S. How about spelling it right? Right, so this is the piece that I wanted to do. I just wonder where that was actually when I was looking for it. Oh, it's actually on page 73. Right, okay. So this is kind of like the same as the previous example. The difference being is that it says here create a Python class. okay, and multiple classes can live in one file. So instead of creating a file, you do this in a class, and the class is like this self-contained container where you calculate. So the class is you create this Python class where you can calculate degrees in Fahrenheit based on a temperature in Celsius and vice versa. So something to flip and switch, and you're given these formulas, so it's the same formula. The temperature in Fahrenheit is the temperature in centigrade. You have to multiply it by 9/5 and then add on 32. And likewise for converting back. So I did this, but actually I don't know if I'm going to call it going one better. I do something slightly different, which is I use a data class rather than a class. And the reason that I use a data class, and I've done a YouTube video on data classes before, the reason that I use a data class is it offers a lot more wrapper functionality than a class. So you can do like some extra pieces out of the box that in a class you'd actually have to write, and it would create like boilerplate code. So the data class kind of like frees you up from that. But anyway, this is kind of like the core piece, and I'm going to open up the code now and we'll just sort of like have a look and see what that looks like. So, and I've got a link as well. I did put a link somewhere. If I go to here, I'll post the link, I guess, to the actual code over here, because it's quite interesting. And this is something that couldn't have been done years ago, so data classes have been introduced into Python and so forth. Let me just go back there. Right, so I shall reduce it, or I'll leave this up actually. We're going to achieve this same piece of code, which is this over here. So this is the actual code that's written, and I kind of like, it took, I don't know, about 15 minutes to write this. There's a little bit of a doc string, and that's the link to the code in the GitHub repository. So it's kind of like over there. That's sort of like the link to it. I'll post it there. I'll put in the author. I don't like, some people do that. But I guess the important piece is this bit here, and I'm actually going to close. I want to. Oh, maybe I'll keep it open. I'll close this bottom bit. The important bit is this import here from data classes, import data class. Now, when I construct this class, which is class temp, I just had to give it some kind of name. Maybe I could have called it temp converter or something else. I just call it class temp for temperature. Also, when we hover over it anyway, it says temperature conversion because the doc string tells us what it is. The difference being that here, normally, if I was to do a class, I would have done something like over here, a def double underscore init double underscore method like this, self. And then I would have put something like, well, not something, value, which was of type float, and str, which is also not str, unit, which is of also of type, it's of type string. So I would have created a method like this. So we can see that this method, if I just get the little drawing tool out here, that the function signature, or at least the pieces of this method, this bit here is exactly this piece over here, and this piece here is exactly looking like this piece over there. But inside of that, so let me just I guess hide that away. Inside of that, inside of the definition, I would have then had to put the self dot value equals, and then some sort whatever, like equals so self dot value equals value, and then I'd have had to do self dot unit equal unit. So, and then I might have also defined the values and so forth and set them in there. So maybe I could have set the value in here equals 0, and then equals, and over here I'd have done equals C. Right. So now we can see that this function looks even more like, and I'll probably have to edit this. So this initialization, if I do actually maybe even put it on a separate line so that we can see this. That's the boilerplate for the code. So we've got the value of float, and we've assigned it a value 0, and unit, which is a string, we've assigned it the string value C, which is exactly the same as here. And then underneath we've had to go and add these 2 extra lines over there. That's pretty much it in this particular case, but you can see that if the class was larger, you'd have to start adding a lot more things in there. But that's not the full game, because basically, like when I do things like the print statements over here, and if I was to run the code, maybe I'll even run it now because I'll have to comment all of this out because we don't want broken code. Right, so I'm just going to run this piece of code. There's some extra free bits that we get out of this, so I can do things like equal, so I can check if temperatures are equal to each other, which you can't necessarily do in a class with a class method without creating some extra code. And there's videos and stuff online, but basically there is an equals method in Python, so def, I think _eq, and that is a way of checking that thing. We can see that it's sort of like done this, like it compares self and value, but the data class gives you this out of the box, so it's kind of like just a little bit more convenient. So I'll just close this up and remove it. So that's what the data class actually does. It lets us focus on sort of like the structure, should I say, and it gives us all of this additional boilerplate. Now, if you do want to do some checks and other things and so forth, you still have to have something that looks like an init function, and that's this post init function. So, which is a little bit annoying because I don't like, I mean, there's a lot of underscores in here, but it's just the way it is. And this post init function is one way for this function basically gets run just like the init function. So it gets run straight after the initializations. So this effectively formed the initialization. So that was part of the boilerplate. So now instead of having an init, you've got a post init. So you've got like an init and another init. And in here, you know, I do some checks, and basically here the check is to check if the, I'm checking here, if the unit is C, C stands for Celsius. So if the unit is C, then we want to convert Celsius to Fahrenheit, and if the unit is F, then we want to convert from Fahrenheit to Celsius. That's kind of like the way that I made this little function. And if it's not, then I've done, so if it's neither of them, then you've made a mistake, or the user's made a mistake, they've put in something wrong. I've created something here, unit, you know, the units given was, and then self.unit, so whatever you would have put in, so if you put in like G instead of C and F, it would throw you some sort of error, it would raise a value error. So it's kind of like a clean way of handling this, and I'll show that as well. And basically, the formula for Celsius to Fahrenheit, we were given that was over here. So I think which way round were we going? Just let me check on that. We were going Celsius to Fahrenheit. So given Celsius, so given this, let's compute Fahrenheit. So let's go, you know, let's get this value. We multiply by 9/5 and add on 32. So the function's relatively simple. So that's actually the function. And the nice thing about this is doing it in the class is we're actually creating, I'm retransforming the initialized value that was set here. So initially it was set at 0 or whatever the user puts in, and then it gets its value gets rechanged, and also its unit gets rechanged. So both of these two fields get flipped. So that's the way that I've interpreted and written this question, written the answer to that particular question. And likewise is a Fahrenheit to Celsius, which is, you can sort of like see that it's a reverse transformation on the function. And in this particular case, in this example, if we were doing Fahrenheit to Celsius, it means that we had Fahrenheit. It means that this one was invoked if self.unit equals F. So we need to set self.unit back equal to C. So that's kind of like the two functions that are embedded. And we can see the indentation. So we've got three pieces in here. We've got the post init over there. And then we've got these two functions over here. 1 and 2, we've got these two functions, and that's basically it. That's everything in this class. So, and the whole class is here, this our temperature class, which, well, I can even put it as a data class. I get that's pretty much everything. And this is like a self-contained unit now, and you can have lots of these classes in a particular given module. So instead of making many modules, if you wanted to or needed to, depending on the data structures, you can do loads of classes. So yeah, that's pretty much it on that side. And then I just write a main function. And what do we do in a main function? We call this class, and this, I guess if you comment it a little bit, when I hover over it, we can see. And again, the data class is read quite nicely. Class temperature, its first value is, its value is of type float, and we've assigned it the value of 0. And the unit is of type string, and we've assigned it C. C represents Celsius. So I just stick in a 10 and a C. But if I was to leave everything, I think, is blank, so I could just do this. In fact, I'll just do it here, like T0 equals temp, like that. Everything's initialized. Right, we're just going to get 0 degrees centigrade. So you could actually even do that, but we're overwriting value. So we're saying 10 degrees centigrade. And then what we're doing is performing this conversion and then performing the conversion back again. So and the reason why we do that is just to check. So hopefully, if everything works, so we take this 10, we transform it into something that's going to give us two new numbers, x and y. X, well, a new number and a new value, so x Fahrenheit. So and that's what we'll get into. That's going to be in T1, and then we're going to feed those T1 values back in. So those T1 values to get T2, and then the T2, we're going to feed those straight back in to get T3. And if all of our functions work, T3 should be equal to T1. So that's basically the check. But we saw that running in the beginning. So and basically here we're going to print the first temperature just to see what came in. So we're just like literally viewing what came in. Then we're going to see this converted temperature. That's the next one. And then we are going to reconvert it back. So that's kind of like the final step. So T1.value won't be the 10 anymore. The T1.value is going to be whatever the converted temperature is. And the T1.unit should flip to Fahrenheit. So this should be Fahrenheit. So I think this should be F here. And this should be some value. That's, I don't know, we'll call it X for now. And then we're going to flip that back again. So we're going to get centigrade here, and then this new value, which will be the original value, hopefully 10 over there. That's basically it. The extra piece that I was talking about now that you get for free is I don't have to put in this additional function. Now, if I did it as a class, this would fail because what actually comes back, well, there's no equals function for a start. And the other nice bit about this is if I just do, well, actually I've done it somewhere, I think, yeah. If I just do a print over here, print of T1, if I just had a class, what I would get back is a memory address. Now, I would have had to have created in the class something like this. So def underscore rep, a repr function, or a string function, something that would actually describe, so like do, and it would work, it would translate and work out the print statement. So again, it's just more boilerplate that now the user doesn't have to do anymore with a data class in Python. And finally, of course, at the bottom, I do the if name equals main idiom and just basically call a main function. The main function's up here. This main function instantiates the classes and runs all of the code. So when I do run this, it's opening the Python kernel, Python version 3.12. We see that the first temperature, and it gets converted to 50, and I guess we could do the check on that somewhere. So if I pull in this calculator and then just do, I guess it's going to be, we put in 10, so it's going to be 10 times by 9 over 5 equals, which is 18 plus 32. So we get the 50, so that value is corroborated, and it's going to be 50 Fahrenheit. So we've gone from this centigrade here, we've done this conversion, and we've got ourselves this new unit of Fahrenheit now. So, and also with this print, we were just able to put this in. We didn't get a memory address. We actually got this nice looking thing, which was the class, its value, and its attributes and the values of those attributes. So we got everything that was in there. So that's the first temperature. That's what happened. We had this transformation. Then we fed the values back in, those values from T1 back into T2. And where are we there? Yeah, so if I just remove all of that, we have the 50, and the 50 we're going to, I think is what the formula is somewhere. Let's pull up that formula. So we've got to take off 32, multiply by 5 and divide by 9. So minus 32 equals, and then multiply by 5, divide by 9 equals, and then we get 10. So we get back to where we are. So we get this next piece over there. And yeah, that's pretty much it. And then we convert one more time. So we do a T3 to get the value again, which is 50. And then we do this little check here. We check that T1 is equal to, is T1 going to be equal to T2? Now we've done one transformation. So we started at T1, we've done a transformation, we got to T2. Now they're going to be different. And of course they are different because we can see that T1 here is 50 in F. And we can see that T2 here is 50, is 10 and C. And we do the conversion back, so we're doing this reconversion, and we get this T3, and we can do this check, and we didn't have to write that extra boilerplate. So that's basically the final piece of it, which is this data class enabled us to do quite a bit more. We were able to check if there was an equals. We were able to do the print statement. So it just saved us a little bit. The negative is that there's this uglier looking function. So rather than just having an init function, you've got this post init function. Oh, and just on the value error, so let me just put in something like, if I was to put in G and rerun it, we get this value error, and it's put here that we can see it's quite nice. This little feature here, this raise error, it lets you actually create, it lets a user create, or the coder create a string here, and in the string you can describe what the error was. So unit given was G, unit needs to be C or F, so it's kind of like a hint, and the user can see where that error actually got risen. So it got risen here, and then you could go and fix the code. You can go and look and fix the code. So it needs to be either a C or an F. I wonder what happens if I put in F. I'll get different values. Yeah, there we go. We get like some odd little values, but we return to ourselves. Now, one thing that I can point out straight away is that we get a false and a false. So I probably need to, I reckon that's because of rounding, and yes it is, like that last unit over here, if I select, circle them. So I probably have to do some kind of rounding to make sure that the equals actually is equal. So you get some floating point errors. Maybe I'll actually make that a little fix in there. So I wonder if I can do that fix. I'll do that. I'll attempt to do that fix now. go back. So what would we do? I guess we might round it here, so we might round it to a few decimal places. So self dot value equals round self dot value, like that, and that would also be true over here. And I think in the rounding we'd have to put, if I do that, we can see number of digits, so let's just round it to 3, because that's probably more than enough accuracy for most things. You know, we can go up to 5, 6, 7 digits, but I'm not sure that we're ever going to need that accuracy, and that might actually fix that particular issue. Let me just rerun this code and see. Yeah, and then we get a false and a true. So yeah, we do have to be slightly careful. That always actually happens. It's interesting. It's good that it gets thrown up, and it gets thrown up in real time. So I kind of the coder or the person making the video has to like attempt to fix it in real time. That's one fix. I wonder if there's another fix for this particular for that particular. You're welcome to put comments in for another way of fixing it. I'm not sure, but yeah, they might. There's probably a few different ways. I was thinking of maybe formatting the string, but if I was to format the string, that wouldn't quite be the same. So, as in, I could have done some sort of formatting .2f, but actually, I don't think I could have formatted like this in any case, because this is actually two pieces is actually the result of a wrapper. So I would have then, and maybe this is like potentially the disadvantage of a data class, is you'd have to like then in the def underscore. So if I did have this def double underscore wrapper function, or had a def double underscore st, I think is a string function, like either one of those, which would print something out. I think this one goes out to coders. I tend to always use this, and this one goes out to users. But either way, like you would have had to like do a modification in one of these two, which you could do a nuance. Again, I think you can actually do it. And in fact, if I did Control Z, I think if I did that, then it would actually overwrite what was in the class, but then I'd be sort of like defeating the purpose of using a data class. So I kind of like want to use the functionality. But in any event, they still would be unequal. So it's still have thrown a false, and you'd be, oh, why are they throwing a false? So yeah, you do have to sort of like consider rounding when you're doing floating. When floating point arithmetic does arise, and it's going to arise in a situation like this, I guess, because you've got some sort of multiplications where you've got divisions, basically, is where you're going to get the floating point arithmetic errors potentially. So that's basically it. The code again lives. It lives. Well, I'm going to put the link in there. So I'll put the link in the actual. I'll put the link in the video. And yeah, that's it. It's kind of like a quickish video. I wonder what else is actually on here. If you, by the way, if you like it, you know, subscribe, follow, all the rest of it. And these are all just like live coding things. So I sort of like just do this. Generally speaking, actually, I haven't coded them before. So this one I sort of like wrote before, and then came back like 2 hours later and created the video. But yeah, like I wonder if I should do one of these other ones. But generally, if you do like it, hit the like, thumbs up button, the follow button, link to other people, and all the rest of it. Yeah, and I think that'll be the end of it. I'll make a new video for other stuff. I wonder if I should do file handling in the comments, maybe. But I don't know, put another comment or something. What you know, what's useful to see. But everything I do, I'm going to kind of like do in real time. I don't want to do the pre-recordings because I don't know, it's a bit more fun doing it live. Maybe I'll get some sort of maybe some people will post comments live on the in the chat. Anyway, that's it. So yeah, thanks for watching, I guess.